So this time we've got a fraction that is not a unit fraction, which just means that the numerator is not 1 multiplied by a whole number. So the process is going to be the same. What we've got is 3 over 7 times 49. And that's a funky looking 49, so I'm going to redo that. So 49, we want to rewrite this as 3 over 7 times 49 over 1, which again, we're going to be multiplying straight across. So if you need a calculator to do this, totally fine. We would have 147 over 7 as our solution to the multiplication there, and then you kind of got to play with it. And again, if you have a times table around or you use a calculator or something, you're looking for numbers to simplify this that are common factors of 147 and 7. So 147 over 7 is actually going to be divisible by, both of those are divisible by 7. And so what we get is 21 over 1, which is equivalent to 21. Now you can use a calculator to do these things, and using wolframalpha.com is not out of the question either. But I will be teaching how to do these things by hand for now, and then later when we get into some more difficult stuff, I'll be using calculators and Wolfram more frequently. But for now, I'll be spending my time trying to teach you how to do these things by hand. So we do end up with 21. And so next we have 3 over 7 times 63. And Wolfram, or I wonder if they're doing this cross-canceling gig. Yeah, Alex likes to do this cross-canceling thing. I will demonstrate that as well in the video. To me, the cross-canceling thing sort of gets in the way of, it seems like a magic trick, and it kind of creates problems for some people. So I'll demonstrate doing this the normal way, and then I'll demonstrate it using the cross-canceling method as well. So 3 over 7 times 63. We would have 3 over 7, 63 over 1 is the equivalent fraction to 63. We multiply straight across, and we would get 189 over 7. Now, 189 divided by 7, let me think for a moment, is going to be 27. And so 189 over 7, those are both divisible by 7. And we will end up with 27 over 1, which is equivalent to 27. The alternative method here, and the way that Alex is going to demonstrate it, is that they would start with 3 over 7 and then multiply by 63. And then say, okay, that's equivalent to 3 over 7 times 63 over 1. And then they do this funky cross-canceling thing where they say, hey, look, 63 and 7 are both divisible by 7, so we're going to divide by 7 inside the problem. We divide 63 by 7, turn it into a 9, divide 7 by 7, turn it into a 1. If that's something that you feel comfortable with, go ahead. I am personally not probably going to do that most of the time. The way it looks and the way you would likely have seen it in school would be looking something like this, where we whack those and we say, okay, 7 divided by 7 is 1. 63 divided by 7 is 9. So we're replacing the 7 with a 1 and the 63 with a 9. And then when we do our multiplication, 3 times 9 is 27, and 1 times 1 is 1, which does get us to 27 a little bit faster. But for me personally, the method on the right feels very much like a magic trick, and I kind of get lost in what's going on, honestly. So if I was to give you some advice, I would say stick with the one on the left and use your calculator to figure out if you can evenly divide these numbers or what their factors are. So that would be my recommendation, but please do whatever is going to work best for you. We'll do 2 more here. We have 5 over 7 times 49. And again, I will demonstrate both methods. So 5 over 7 times 49 is going to be equivalent to 5 over 7 times 49 over 1, which is going to give us 245 over 7. And again, this is a great place to use a calculator to say, hey, is 245 divisible by 7? The answer would be yes. You would end up with 35. And so 245 over 7. If I divide both the numerator and denominator by 7, I get 35 over 1, which is equivalent to 35. Alternatively, you could do the cross-cancel thing inside the problem. You would start the same with 5/7 times 49. Change that to be 5 over 7 times 49 over 1. And then inside the problem, you would recognize that 49 and 7, and notice that these are diagonal of each other. That's a big deal. The 7 and the 49 are on opposite diagonal corners of this problem. We would divide both of them by 7. The 7 would be replaced with a 1. The 49 would be replaced with a 7. And we would get to our answer more directly. 5 times 7 is 35. 1 times 1 is 1. Either method produces 35. Again, to me, the one on the right feels a bit like a magic trick, and I will choose most of the time to stick with the method on the, the one on the right feels like a magic trick, and I will most of the time choose to stick with the method that I demonstrated on the left. And so we'll do one more. Gotta create some space. So pause here and take notes if you need to, because I'm going to erase this piece in 3, 2, 1. So the next thing for us is we're going to have 3/8 times 72. And we're going to convert that to be 3 over 8 times 72 over 1. And that's going to give us 216 over 8. And again, a calculator is fine to use to do these things. So 216 divided by 8. I'm going to think for a moment if 216 is divisible by 8. I think it is. And so we're going to try it. Again, I would probably pull my calculator out at this point. And I'm going to try and do it in my head and see how close I can get. So 8 times 20 is 160. That leaves 56. 8 times 7 is 56. That's what's left. So that would be 27 over 1, which is equal to 27. And so when I do some mental math and things like that, I'll talk through the process that I use to do that as well. And hopefully that is helpful. It is 27, and I am going to demonstrate the cross-canceling method here as well for this problem. So 3/8 times 72 is equivalent to 3/8 times 72 over 1. For cross-canceling, what would happen is we would recognize that 8 and 72 are both divisible by 8. 8 divided by 8 makes 1. 72 divided by 8 makes 9. Then we have 3 times 9 is 27, and 1 times 1 is 1, which also produces an answer of 27. All right, choose your method. Either is okay with me. Whatever is going to work best for you is what I would recommend.